Good afternoon, everyone. Before we jump into the slides, let me tell you what we are learning today. We are basically breaking down how cloud providers make things work behind the scenes. You use cloud every day Canvas, Netflix, Gmail, but you never see the inner wiring. Today, we are going to walk through the architectural patterns that make the cloud fast, reliable, scalable, and cheap enough to use at a massive scale. Some of these patterns are about performance, some are about storage, and some are about networking. But they all have one goal: keep your apps running even when millions of people hit them at once. By the end of this, you will understand why the cloud looks the way it does and how all of these pieces connect. Cloud architecture basically means all the different ways the cloud is organized behind the scenes. You see three bullets here: modern systems, performance scaling issues, and explaining patterns. And that's really what this whole thing is about. Companies like AWS or Azure don't just throw servers in a corner and hope things work. They build patterns that solve problems that are speed, reliability, cost, and that annoying moment when suddenly a million users show up and your system panics. So today we're walking through each of those patterns. Okay, the slide says VM normally goes through a hypervisor. Direct IO here is input output. Talks to hardware, why it matters, latency. Keep those 3 points in mind. VM normally goes through the hypervisor, direct IO talks to the hardware, and why it matters, latency. Right now, every VM you've ever created, Azure, AWS, whatever, usually sends its storage or network request through the hypervisor. That's like going through a receptionist every time you need anything. It's safe, controlled, but it's slow. Direct IO, which you'll see on the second bullet, cuts out that middle step. The VM talks directly to the hardware. And the third bullet says why lower latency. When you remove middlemen, things just move faster. It's the difference between talking to a manager directly versus telling an intern to go find the manager for you. The high performance database, real time analytics, predictable performance. And the limitation, migration. That is, migration becomes harder. If you're running something like financial trading systems, you don't want 20 microseconds of unnecessary delay. The same if you're running a big analytics pipeline that's processing tens of thousands of queries a second. If VM is directly plugged to the hardware, it's much harder to move it somewhere else. It's like installing your washing machine directly into the wall instead of using a connector. Moving it becomes a nightmare. Dynamic data normalization. Slide says hot versus cold data, fast versus cheap storage, balance cost, and performance. Think of your laptop. Your most important apps stay on your SSD. Older stuff goes somewhere slower. The cloud does the same. It's automated. So hot data, stuff that you keep using, gets moved to a faster storage, and cold data, the data that nobody opens, gets moved to a slower, cheaper storage. That's how cloud companies save you money without you even noticing. The slide lists AS3 standard, IA, and Glacier. That's the AWS version of hot, warm, and cold. S3 is standard, stuff companies need on a daily basis. S3IA, IA stands for infrequent access, stuff you check sometimes. Glacier is digital attic, cheap but slow. The bottom bullet, the cloud does this behind the scenes, is an important one. You don't touch anything. AWS quietly moves your data around. Elastic network capacity. We here talk about elastic bandwidth prevents congestion and handling spikes. Elastic network means the network automatically adjusts itself based on the demand. So if your app suddenly goes viral or it's Black Friday, the network expands so everything doesn't call. The prevent congestions part is huge because the traditional on prem servers congestion kills performance. In the cloud, the network can stretch out. Noisy neighbor is the classic cloud problem. Someone else on the same hardware is hogging down resources. Elastic Network reduces that impact. Your app stays responsive because the network gives you more room. Autoscaling also depends on this. If you add 10 more servers because traffic spiked, the network must be able to handle that. Otherwise, autoscaling is useless. Storage tiering. Three tiers on the slide are NVMe, SSD, and hard disk drive. Fast, medium, and slow. This is vertical tiering. The cloud constantly shifts your data between these based on how active that data is. NVMe for speed, hard disk drive for cost, and SSD is the middle ground. Intra-device tiering. SSD has fast and slow regions, controller moves the active data. This is literally inside a single SSD. The chip has different types of cells, some extremely fast but small, others slower but larger. The SSD controller moves your frequently accessed data into faster areas so performance feels snappy. Load balance virtual switches. Inside the cloud, your VM network traffic is handled by software switches or virtual switches. But instead of sending everything to one route, the system spreads out traffic so no individual path gets stuck. There are so many routes from the virtual machine to the internet. That's literally what happens. If one route is slow or congested, the system reroutes traffic so you don't really have to do anything. Everything is automatic. Edge computing is all about location. If your device needs instant response, like a VR headset, self driving car, or a smart camera, you don't have to wait for the data to travel across the country or to a big data center. You have all of the computing right there within the device. Fog computing is the middle layer. It sits between the edge and the cloud. It's like a local helper. Instead of sending millions of tiny IoT readings into the cloud, the fog device collects and filters or pre-processes them and sends out to the cloud. Virtual data abstraction. The cloud never shows you the real disk. You only get virtual disk because that allows the cloud to move your data anywhere it wants. It could be different servers or completely different racks. It does that without breaking anything. That's how migration and scaling seems easy. And more on this exposure level architectures in the next class. That is all for today. See you all on the next Monday.